Okay, this video is going to be about conditional statements. We have 3 EQs for this video. What is a conditional statement and the related conditionals? What is a biconditional statement? And what is a counterexample? So if I were you, before we start, I would make sure you have a couple different colors. We will be color coding in this video, so I would recommend having at least 3, possibly 4 different colors to color code. So let's go ahead and get started. You should have a printout from class, so make sure you have that taped in your journal, ready to go. So the first thing we're going to cover is a counterexample. A counterexample is proving a conjecture wrong. So it proves a conjecture false. So false being the key word there. It proves it wrong. Counterexample is proving it wrong. So it could be a number. It could be a picture. Or it could be a statement. Could be any of those to prove something wrong. So that's our first vocab word. The next slide should match your printout. So I'm going to be using some color coding here. So parts of a conditional, we talked about this in class. So it is if, and then hypothesis, then the conclusion. So I'm going to use some colors here to code what I'm writing. So I'm going to use purple to note my if and my then. I'm going to use blue for my hypothesis and green for the conclusion. So you can kind of see what's going on there. So if hypothesis, then conclusion. Sometimes we refer to the hypothesis as the letter P and the conclusion as the letter Q. So we could also say if P, then Q, just kind of a shorthand way to say it. So let's go ahead and write in our definition for the conditional. They are statements in the if-then form. So let's go ahead and write that part in. Statements in the if-then form. So our first example is going to be if I get a 100, then I get an A. And we're going to identify the truth value for that statement. So I'm going to first color code my if and my then in purple, my hypothesis in blue, and my conclusion in green. So you can kind of see all that there. And then we're going to look at the truth value. If I get a 100, then I get an A. Well, if you get 100, yes, you get an A because an A is from 90 to 100. So go ahead and put a T. That one is true. We're going to move on to the related conditionals, which is the next part of your chart, the converse, the inverse, and the contrapositive. So I would write down those definitions and then fill in the examples along with the video. So for a converse, to write the converse, you're going to flip the hypothesis and conclusion. So I'm just going to draw a little arrow that shows you are swapping their places. So it's still going to read if something, then something. It's just that the hypothesis and the conclusion have been switched. So from our previous example, it's going to be still if, still then. But in this case, it's going to be if I get an A, then I get a 100. And we're going to color code. So purple for the if and the then. Blue is now, it's still that I get a 100, but it's after the then. And then green, I get an A. So we're going to look at that statement, identify the truth value. If I get an A, 0 to 100, then I get a 100. Well, that's not necessarily true. So we're going to put false. And if we're going to put false, you have to have a counterexample, which remember, proves it wrong. So we're going to put our example, our counterexample here. And let's say you get like a 91. It's still an A, but not 100. So it proves that statement wrong. So now we're going to move on to the inverse. The inverse is to negate the original, which means add not to the hypothesis and conclusion. So I'm going to say add not. That's just my little extra note. So it's going to read like this. If, and then still both there. So if I do not get a 100, then I do not get an A. And let's go ahead and underline in purple the if and the then, and then our hypothesis in blue, I do not get a 100, our conclusion in green. And then I'm going to add a color to it, red, and I'm going to box where we have negated, so adding, whoops, that's not red, where we have negated our statement, so not and not. So now we're going to analyze our statement and find the truth value. If I do not get a 100, oh, my conclusion was not underlined. There we go. If I do not get a 100, then I do not get an A. So if I didn't get 100, does that mean that I did not get an A? Well, an A is from a 90 to 100, so that's false. And again, if it's going to be false, you've got to have an example. So for example, you could have gotten a 98, which is an A, but not 100. So it proves that statement wrong. We're going to move on to the third one, contrapositive, and you're going to do both things. You're going to flip and negate. So you're going to do both. So I'm going to say do both, and then I'm going to draw the picture. Flip and add not. So we're going to flip the hypothesis and conclusion and negate it. So you're going to have if and then. And it's going to read like this. If I do not get an A, if I do not get an A, then I do not get a 100. We're going to go ahead and underline in purple my if and my then. And then since I have flipped the hypothesis and then the conclusion, the hypothesis is down here in blue, the conclusion is up here in green. And then I'm going to go ahead and box my not in red, so I can see. So let's analyze that statement. If I do not get an A, then I do not get 100. Well, an A is from a 90 to 100, so if you didn't get an A, you did not get 100, so that one's going to be true. There's no counterexample for that. So we're going to draw our conclusion from that, and it says, if the conditional is true, then the contrapositive is always true. So the contrapositive and the conditional are always true together. And if the conditional is true, then the converse and inverse are always false. So you can see there, they're always false. So if the conditional is true, the contrapositive is true. If the conditional is true, the converse and inverse are always false. So we're going to look at another example, one more that you should have a chart for. And I have the statement up here for you. The midpoint M of a segment bisects the segment. So it's up here in red. We're going to write that as a conditional statement. Then we're going to write the converse, inverse, and contrapositive and analyze the truth value and give a counterexample if we can. So here we go. So the midpoint M of a segment bisects the segment. So we're going to write our original conditional. If M is the midpoint of a segment, then the segment is bisected. So in purple, I'm going to put my if and then. In blue is my hypothesis. M is the midpoint. And then in green, the conclusion, the segment is bisected. Now notice that the hypothesis and the conclusion are not including the words if and then. The hypothesis does not include if. The conclusion does not include then. So they are separate from that. So let's analyze that statement. If M is the midpoint of a segment, then the segment is being bisected. Well, that is true. If you have a midpoint on a segment, then that segment is being bisected because the midpoint is cutting that segment into two equal pieces. So now we're going to write the converse. So the converse, we're going to, remember, flip the hypothesis and the conclusion. So if the segment is bisected, I'm going to go ahead and put my if and then there. If the segment is bisected, then M is the midpoint. And we're going to go ahead and underline in purple my if and then. And now I've flipped my hypothesis and conclusion. So M is the midpoint, is still blue. My conclusion, the segment's bisected, it's now moved up there, and it is in green. So let's look at that statement. If the segment is being bisected, then where it's being bisected, M is the midpoint. Well, that's true, because if it's being bisected, it's cut in 2 equal pieces, and if that point M is there, then that's the exact middle, that's the midpoint. So that is true. So now this example looks a little different. The conditional is true, and the converse is true. So this is going to be a special example. Now we're going to do the inverse. So the inverse means to add not. We're going to negate the original conditional statement. So if and then. So if M is not the midpoint, of a segment, then the segment is not bisected. Okay, so in purple, I'm going to underline my if and then. And then in blue, my hypothesis, M is not the midpoint of a segment, and in green, the conclusion, the segment's not bisected. And then same thing, I'm going to take red and I'm going to box where I have negated the statement. So M is not the midpoint, then the segment is not bisected. So let's analyze that statement. If M is not the midpoint, then the segment is not bisected. Well, if you don't have the midpoint there, then that's true. It's not being bisected, so that one is true. So now we have the conditional, the converse, and the inverse that are all true. So we're going to move on to the contrapositive, where we're going to do both. We're going to flip it and add not. So if the segment is not bisected, then M is not the midpoint. So if the segment is not bisected, then M is not the midpoint. And we're going to color code. So in purple, if and then. In blue, my hypothesis, which has been flipped, so it's down here. My conclusion in green. And in red, box where we've negated. So the segment is not bisected, so M is not the midpoint. So let's analyze that statement. If the segment's not being bisected, then M is not the midpoint. Well, if it's not being bisected, you don't have a midpoint. So that's true also. So this is a special example where all the conditionals and its related conditionals is true. So that is a special example, which takes us to our next slide. So a biconditional statement is a statement that can be written in the form P, which is the hypothesis, if and only if Q, the conclusion. So let's fill that in for P and Q. So P, remember, that means our hypothesis, and Q is the conclusion. So that means you can say if hypothesis then conclusion, and backwards, if conclusion then hypothesis. So it's true in both ways. So we're going to write the biconditional, and I'm going to use probably black and red to write this, not all of my colors. So this statement would read, M is the midpoint, and then I'm going to switch to red, and I'm going to say if and only if, and now this is my conclusion, the segment is bisected. There we go. The segment is bisected. And so since this is a biconditional, we can also write it in the opposite way. So we could say The segment is bisected. The segment is bisected if and only if M is the midpoint. So we have a biconditional statement. That means the conditional and all its related conditionals are true. You can write it as hypothesis if and only if conclusion, and then you can also write it backwards, conclusion if and only if the hypothesis. And all of those have to be true. So in our conclusion, if the biconditional is true, the converse, inverse, and contrapositive are all true. So the converse, inverse, and contrapositive are all true. So make sure you have these notes taped into your journal and bring them into class the next time we see you.